All right, and welcome back. So today we are going to be talking about the division properties of exponents. The division properties of exponents are going to be very similar to the multiplication properties of exponents, since multiplication and division, we call them opposite operations. So the exponent properties are going to be similar, but just a little bit different. And let's talk about what I mean going through your guided notes. On the front page, we're going to talk about the quotient of powers property. We can use that to divide terms with exponents. In the algebraic representation, if we have a to the mth power divided by a to the nth power, that's also equal to the base of a to the m minus n power, assuming a is not 0 and m and n are integers. This is the opposite of the product of powers property, where we would be adding the exponents together. Now, since we're dividing, we're going to be subtracting those exponents together. So let's go through an example to show you what exactly we are talking about here. Let's say we want to simplify 7 to the 5th divided by 7 squared. We could do expanded form, 7 times 7 times 7 times 7 times 7 in the numerator, divided by 7 times 7 in the denominator. That is going to be a whole lot of work, and we want to make things simple, right? We want to work smart here. So we can use the quotient of powers property here. We have the same base of 7, so we can do 7 to the 5 minus 2 power, and we're going to get 7 to the 3rd, which is a lot easier than using the expanded form, maybe canceling some stuff out, and then seeing what we have left over. We can just say it's going to be equal to 7 to the 3rd. By the way, 7 to the 3rd is 343. So it's a decent sized number. On the right-hand side of your page, let's talk about how to simplify x to the 7th times y divided by x to the 3rd. Well, we can rewrite x to the 7th and x being divided by x to the 3rd as x to the 7 minus 3 power times y. And we end up with x to the 4th times y, because x to 7 minus 3, that's x to the 4th. Awesome. We can also use the positive power of a quotient property. This can be used to raise quotients to positive powers. So the algebraic representation of this is if we have the fraction inside a set of parentheses, so a divided by b, and all of that is getting raised to the nth power, we can essentially distribute the exponent of n to the numerator and to the denominator. So we end up with a to the n divided by b to the n. Again, where a is not 0, b is not 0, and n is a positive integer. Let's go through an example or two. On the left-hand side of your guided notes, we have the fraction 2 over 5 getting raised to the 4th. Well, we look inside the parentheses first. We have 2 over 5. We cannot simplify that. So now we're going over to exponents. And we're going to use this positive power of a quotient property. And we're going to essentially distribute the 4 of the exponent to the 2 and to the 5. So we get 2 to the 4th divided by 5 to the 4th. And we can simplify this and get 16 over 625. The key here is we want to simplify inside the parentheses before we start our properties of exponents, because our order of operations tells us to do that. Parentheses, exponents, multiplication or division, addition or subtraction. Over on the right-hand side of your guided notes, there is another problem, and it involves variables here. Woo! So we have inside the set of parentheses 2 times x to the 5th in the numerator and y to the 4th in the denominator. We want to see if we can simplify anything first, and we can't. We don't have any of the same bases, so we can't apply any previous properties. But we can use the positive power of a quotient property, try saying that 7 times fast, and we're going to distribute the 3 inside to all of the terms. So we have 2 times x to the 5th, that is getting raised to the 3rd power, and y to the 4th getting raised to the 3rd power. We can use the power of a product property to help us distribute again. So we get 2 to the third times x to the fifth to the third divided by y to the fourth to the third. And now we can simplify it here. 2 to the third is 8. X to the fifth raised to the third is x to the 15th. Y to the fourth raised to the third is y to the 12th. You may be able to just send that 3 over and not have to use this step right in here. You may not need to do this step. You may just do it as 2 to the third, x to the 15th, y to the 12th. That is fine. Whichever method, whichever way you want to get there, we're still going to end up with the same answer. So just make sure that we're thinking about the properties and thinking about the rules of these exponents as we are simplifying. Awesome job. With this in mind, please work on problems 1 through 9 on the guided notes and resume when you're ready to move on. All right, if you're listening to my voice, that means you're on the back side of your guided notes. And right now, we're going to be talking about how to divide quotients raised to a negative power by using the negative power of a quotient property. And essentially, what we're going to be doing here is if we have the fraction a divided by b, and that's getting raised to a negative exponent, what we can do is flip the fraction. So now it becomes b over a, getting raised to the positive nth. And that's going to be equal to b to the nth divided by a to the nth. And the reason why is if we used the property of negative exponents and we sent in that negative n, we'd have a to the negative n over b to the negative n. And we know we can't have negative exponents, so we have to flip the location of that base. Well, a is getting raised to a negative nth power. That's in the numerator, so that would go into the denominator. And b to the negative n is in the denominator, so we change that location, and that goes in the numerator. So we end up with b to the n, which is exactly what we ended up using this property. We end up with the same answer, the same ending location. So this is just a little bit of a shortcut for us. Instead of sending in that negative exponent when we have a fraction, we can simply flip the fraction and keep the positive exponent of it. Awesome. With this, let's go through an example of how we would actually show this. On the left-hand side, your guide notes, we want to simplify the fraction 3 over 4, getting raised to the negative second. We look inside that fraction. We have 3 and we have 4. The 3 is the numerator, 4 is the denominator. We cannot simplify. So now we're going to go into our exponents because we checked off the simplification of our parentheses. Well, using the property, we can rewrite it as 4 over 3, getting raised to the second power. We can use the quote-unquote distributive property here, where we send that 2 of exponent into all of the terms, into the numerator and the denominator. Therefore, we end up with 4 squared divided by 3 squared, and we get 16 over 9. Awesome. On the right-hand side, we have another problem, but this one involves variables. Woohoo! So we have inside our parentheses the fraction 3a to the fourth in the numerator and b squared in the denominator. All of that is getting raised to the negative third power. We can rewrite this using positive exponents. We're going to flip that fraction. So 3a to the fourth is now in the denominator and b squared is in the numerator. We have the exponent of positive 3 now because we use this property of exponents. From here, we're going to send the exponent of 3 into all of the terms. Therefore, we get b squared getting raised to the third power and 3a to the fourth getting raised to the third power. And from here, we can simplify all the way down until we get b to the sixth divided by 27a to the 12th. And these is more of these properties of exponents. Great job with this so far, kiddos. You're doing a really, really great job. Keep making yourself proud. Please work on problems 10 through 18 on the guided notes. Let me know if you have any questions. and I will talk to you soon. Have a good one.